Okay, so let me just kind of review all of that for you guys who did or did not get number one. So for number one, we wanted to find the proportion of observations that are less than -1. So we looked at our Z chart, and since in the Z chart, this is areas, then I go and that's what I'm looking for. So I want the answer that's in here. I go to my Z's. So I go down here and I find -1.00. There's where my answer would be. And that means that was 0.1587. So physically what that means on a normal curve is this. If this is your mean at 0, then at 1 standard deviation below the mean, how much area is below the curve, okay? So you guys listen up. These numbers in the Z chart give you areas below that point. So at a standard deviation of at a Z score of -1 away, 15.87% of things are below that point, okay? So that's why then the answer for number one was 15.87%. You could also write it as 0.1587. Okay, but we want to have four correct significant digits on these. All right, so the next problem I want you guys to do is number 3. Okay, underneath the normal curve, how much is the complete area underneath the curve? 100%. So if you have 100% minus this part, that would tell you what's greater. So that's how we get that, and that was 84 point whatever percent. 84.13%. Okay, very good. The next one that I want you guys to do is number 5. So here's this one. Okay, so for number 5, we wanted the part between a Z-score of 1 and 2. So we want this. Well, if you look at your charts, if you looked at your Z chart, that would give you the part below 2. So you go find 2 on your chart, and that would give you all of this. And the area below 2 is 97.72%. That's the area below 2. But then I don't want all of this other stuff. So how do I get rid of all of that part? Subtract off the area below 1. Remember, it's like the big area, take away the smaller area. So I'm going to subtract off this area that's below 1, and the area below 1 is 84.13%. And so that's how I come up with my answer for number 5 of 13.59%. That's the area between the two. Okay? I subtracted 1 from the other one. That's all I did. Yep. Okay, so the next one I want you to do is number 6. You know, y'all are starting to get to where you're just, going through the chart and using that pretty well. But please don't forget to have a physical idea of what's happening. -0.2 is below the mean 0.2. So it's actually a higher area. It's actually more area than the -0.6, isn't it? So the -0.2 was a larger area that you subtract away the -0.6 area, and that is how you got your answer of 14.64%. Okay, all right. The next one that we're going to do, the next one we're doing is number 8. Number 8 is the next one online for points. About half of you did not give me the correct significant digits on this, and so let's go over it. When you look at your Z table and you look at, we're talking about 95% are below what value, okay? So we want to know what our Z score is with an area of 95. So we go look in our table, because that's where the areas are. We go look for 0.95. And what happened? It was not exact. What was it in your table? It was like on either side of it. 0.9485 and 95, and then this one was 0.9505. And so your area was right in the middle. Therefore, you could come here and here, and you find that it's 1.6? Yeah, 1.6 here, and it's not 0.04, and it's not 0.05. What's in between 0.04 and 0.05? 0.45. So the answer is 1.645. Furthermore, we're about to get into some that are not even perfectly in the middle. Therefore, I, at this point, am going to now teach you some calculator skills that you'll need to know if it does not come up directly on your chart. Okay? So here's how that goes. There are two things in your calculator, and actually let me find a blank page to write on first. Okay? There are two things in your calculator that you want to be able to do. One of them is this. Okay, so you guys follow along. In fact, I would even write this on your yellow Z chart because you want to have this as you are practicing, but you cannot use it on tests. So make sure you know that I will be giving you a laminated copy of the Z chart without this stuff on there, but this is for you just for your initial helping. There's something that's norm CF, and there's something that's called inverse norm, and those are the two functions on the calculator that are going to help us. One of them, and here's how, and it's hard. This summer when I was trying to do this, I couldn't figure out the difference between these two, and I was getting mixed up, and I'm like, oh, how am I going to remember which one's which? Well, here's how I have decided to remember it. You see this C right here? That C stands for cumulative area. So if you do this function, the answer you get is a cumulative area. In other words, it will tell you how much area is under the curve from that point down. So if you want to know from that point, what do you need to put in? What do you need to put in to get some areas out? You have to put in a z-score. Okay? So we have to put in like the bounds of our z-score. Furthermore, we can put in a left bound and a right bound, and it'll give us the area in between those 2 points. So I could put in, I put in one z-score, and then I separate it with a comma, and I put in another z-score, and that would give me the cumulative area between those 2 points. Okay. Inverse norm is the opposite. So instead of putting in a z-score, what do you think I put in? Put in an area, aka 95%, it's below 95%, and what do I get out? I get out the z-score. Very good. So when I put it in my calculator, I get out a z-score. Okay. So that's what you need to know, and now let's practice it on the calculator. Okay? Remember, number 8 said, what is the z-score that 95% fell below? So that's an area of 95%, right? So if it's an area of 95%, I'm going to use this thing here, an area of 95%. So here's where that is on your calculator. Turn your calculator on. It is under distributions, so it's second bars. And see, look, it's number 3. So you hit enter and put in the area. What's the area that I put in? 95%. You have to put it in as a decimal, 0.95. And there is the z-score that falls at that point. And what did we round it to? 1.645. Ta-da. Okay, so let's do a sample of the other one. Here's a sample problem. I think so, yeah. Hey, I want you to find the area that I've highlighted here. And I'm going to tell you that that's between, it looks pretty symmetric. So if I said that this was -1 standard deviations below, why do I know that was a negative? Because it was on the left of the mean. And this one's a +1. So those are my two z-scores. And I want an area. Which one of these do I use? If I want the area and I have two z-scores, use my normal CDF. So go to your calculator. What? Yes, you would. So on my normal CDF, I would put my left z-score, comma, my right z-score, and boom, 68.2826%. Hey, and remember from our previous notes that how much percent falls between -1 and +1? 68%. Okay? Of course, they rounded it. Okay, all right. So with that all done, no, I want you to go ahead and keep things to 4 significant digits. I would like for you now to go do the next one for you guys to get to do is number 11. I want you to do number 11 for points or for the contest. Okay, go. All right, so let's talk about this one. This question said to find the value, in other words, find the z-score that is separating this percentage of area from this percentage of area. That is really, you have to understand what these questions are asking. Find the z-score that separates this percentage of area from this percentage of area. Well, bottom 60 would put it above 0 because the mean is at what? 50%. So it's going to put it here. So this would be below this. Oh, well, dang it. I hate it when that happens. Below this, that would be 60%. And above this would be what? 40%. Now, when we calculate and use our z-chart or use our calculator, it gives us areas that are what? Above the point, inflection point, or below that inflection point? Below. So which one of these numbers, 60 or 40, do I need to use? 60, because I need to put that in. So that's an area. I need to go to my calculator, because remember, if I have the area, I'm going to use this inverse norm right here. Okay? So I'm going to go to my calculator. I'm going to put in, because actually I tried it in I looked it up in my chart, and it didn't come up exactly. So I'm going to do it here and go inverse norm, put in an area of 0.60 or 0.6, and that gives me that. Now, interestingly enough, what was the inverse norm of 0.40? The opposite of it. Why is the 40, if that's because that's that area? And it's symmetrical because it is a standard normal curve. So 0.2533 here is here, and negative 0.2533 is symmetrically on the other side. So it was the positive one because we wanted below 60%, not below 40%. Oh, because I didn't draw it very well, but it would be, I mean, how is it symmetrical if they don't look symmetrical? Well, let me try to draw it better. Okay. %60 is below this. 40% is above this. But this one, 40% is below it, 60% is above it. So this is the same as this. Yes. It's like it's flipping around the origin, which is the mean. Okay, so this was positive 0.2533. Oh, and then let me go over the other mistake I saw. Okay, hello people. This is not in percentages. I do not give my answer as 25.33%, nor is it this answer, 0.2533%. This is a z-score. A z-score has no units, and it's not an area, so it's not a percentage of area covered. All right, it's just that number. Okay, the next one for you to do is we got to get to number 17. The last one is going to be we'll do 14. Yeah, we'll do 14. Now, 14 is a good one. Number 14. This one, you know what? We have a three-way tie going into our contest, and so I think this one's going to be our tiebreaker maybe. Okay, so let's talk about number 14. We want to find the proportion between. Okay, so that's saying we want to know how much area is between 174 and 185 when we don't have a standard normal curve and our mean is 174. Well, in order to do that, we have to know, what are we talking about as far as where these items fall and what their z-score is. So I'm going to find the z-score of 174. Okay, so it should be obvious to you, and this is the data minus the mean over the standard deviation. Okay, but it should be obvious to you that since 174 is the mean, it's a z-score of 0. So 174 has a z-score of 0. So let's see what the z-score for 185 is. So that would be 185 minus 174 over 21.1, and that's a z-score of 0.5213. So if this is 1, then I'm going to have a z-score somewhere about right here of 0.5213. That's my z-score, 0.5123. Okay, so let's go back to the question. What is the proportion or the area between those two values? So I'm going to find the proportion between those two z-scores. So I could go to my chart and look it up and find the area, the larger area, and subtract away the smaller area, which would be a half, because the area down here below 0 is a half. Or I could think, okay, I'm going to go use to find my cumulative area, I'm going to use this thing. And I'm going to put a z-score of 0 in to a z-score of 0.5213. So let's go to your calculator and do that. So I'm going to go to second VARS, normal CDF from 0 to 0.5213. And there is how you get the area, which you can state as a decimal, 0.1989, or as a percent. To me, it makes more sense to state things as a percent, because here's what that's saying. .89% of data is in between the numbers 174 and 185. Okay? So that's what that was saying. All right, the next one that I want you to do is, and this will be the last one that we're going to cover, but it's a really, really important one. And so I want you to do number 17. So let's spend a little bit of time on number 17. Okay, so let's go over number 17. Number 17 has a mean of 100 and a standard deviation of 15. So if you're thinking about what this is looking like, at one standard deviation, or one standard deviation, I'm going to add 15. So this number is 115. I'm going to add 15, and this number is 130, and so on. And you could do the same thing over here. This would be subtracting 15, and so that number would be 85. Okay. And this would subtract another 15, and that number would be 70. Okay, so that's your anatomy of your normal score if it was not standardized according to this problem. Okay, but what we want to do is use the middle 90% of area. So if we want to do the middle 90% of area, that's going to be cut off the top 5%, and that's going to cut off the bottom 5%. So the area that we are talking about is all of this right here in the middle. Okay? So in order to know how much area that is, first of all, I have to turn these things into z-scores. So I need to turn this 5%, or find out what z-score is at 5%, and find out what z-score is at 95%. Okay. So I'm going to put in an area of 5% and get its z-score. I put in an area, so by now you should kind of start being able to go around these. If I'm putting in an area, I'm doing my inverse norm of 5%, and so that's a z-score of negative 1.645. Now this is symmetrical, so because I know that, I should automatically know that this is positive. But let me go ahead and show you that. Now this is the bottom 95%. So if I did my calculator and I did inverse norm of 95%, then I get the positive value of that z-score. Okay. So at this point, I want to talk about the ambiguous wording of this question. It was unclear to me the first time I read the question if I was looking for the difference in the z-scores. If I was looking for the difference in the z-scores, then I'd be wanting to know, okay, well, what's the difference from 1.645 minus a negative 1.645? You know, so add those two things up and you get 3.29 or whatever it is. So, you know, that could be a translation to this problem, but I emailed the person who wrote this worksheet, Miss Smeltzer, my AP idol, Miss Smeltzer, and found out that her intent of this problem was not that, to find the distance in those. Rather, her intent of this problem was to find out the difference in the scores as related to a mean of 100 and a standard deviation of 15. So what that means is that I got to figure out then, based on this 1.64, what value is that? If this is 100 and I need to go up, I need to add to it 1.64. If I just added one standard deviation, that would add 15 and get me to 115. But I need to add 1.645 standard deviations. So I get that by saying 100 plus 1.645 standard deviations. And that's how I get this value right here. Not at 115, but that ends up being a value of 124.675. So that's the number that is there at the 1.645 standard deviations above. So how would I go over here and find the number below? I would say, okay, 100 minus my 1.645 standard deviations below, and that puts it at 75.325. Okay. So those are my two numbers that I have separating the middle 90%. But we have to take that one step further because we want how much separates them. So I take my 124.675 and I subtract 75.325 to find out that distance separating those two values, and that distance separating those two values is a final answer of 49.35. Okay, so many, many, many multiple steps there. You have to know and be able to go in and out of your anatomy of your normal chart, whether it's standardized or not. Okay, so that's all of that, and then you would be finishing the rest of those problems for the normal curve day one, normal